Okay, today we're going to be talking about motor stopping methods. So electric motors produce rotary motion that is used to produce work and applications that range in requirement, size, and environments, as well as other conditions. We know that all electric motors require power to get them started and to keep them running. So once running, all motors will stop rotating when power is removed. For most applications, removing power to stop motor rotation meets the needs of the application. However, in some applications, consideration must be given to stopping a motor or by some other method than just removing power and allowing the motor to come to a stop based on the motor's operating speed and the load applied to the motor shaft. In applications that require a faster than normal stop or a controlled stop time, you're going to have to use some type of braking method that must be applied. There's going to be several different methods used to stop a motor. Usually one method is best to meet all the requirements. Learning how motors can be stopped is important when designing or working on circuits in which faster motor stopping can provide a safer operating condition for the driven parts and persons working around that equipment. First one we'll talk about is friction brakes. The length of time required for a motor to come to rest depends on the inertia of the moving parts, which is going to be your motor and motor load, and friction. So the definition of inertia is the property of matter by which a mass persists in its state of rest or motion until acted upon by an external force. Friction is the resistance to motion that occurs when two surfaces slide against each other. Friction brakes normally consist of two friction surfaces with shoes or pads that come in contact with a rotor mounted on the motor shaft. Spring tension holds the shoes on the rotor and braking occurs as a result of the friction between the shoes and the rotor. So friction brakes can either be magnetic or mechanical, and they are the oldest motor stopping method. Friction brakes are similar to what we'd find on our cars. Solenoid operation. We know that solenoids are all around the electrical world. Friction brakes are normally controlled by a solenoid, and that solenoid is what activates the brake shoes. The solenoid is energized when the motor is running. That's going to keep the brake shoes from touching the drum mounted on the motor shaft. And the solenoid is de-energized and the brake shoes are applied through spring tension when the motor is turned off. Two methods are used to connect the solenoid into the circuit so that it activates the brake whenever the motor is turned on and off. The first method is used if the solenoid has a voltage rating equal to the motor voltage rating. The second method is going to be used if the solenoid has a voltage rating that's equal to the voltage between line 1 and the neutral. The brake solenoid should always be connected directly into the motor circuit, not into the control circuit. This eliminates improper activation of that brake. So some disadvantages versus advantages of friction brakes. So the advantages of using friction brakes are their lower initial cost and simplified maintenance. Friction brakes are less expensive to install than other braking methods because fewer expensive electrical components are required. Maintenance is simplified because it is easy to see whether those shoes are worn and if the brakes are working. Similar to automobiles, you can see if your brakes are worn. Friction brakes are available in both AC and DC designs to meet almost any application requirement. Some disadvantages of friction brakes are they require more maintenance than other braking methods. So maintenance is going to consist of replacing the shoes and pads regularly. Shoe replacement depends on the number of times the motor is stopped. A motor that is stopped often needs more maintenance than a motor that is rarely stopped. Friction brake applications include printing presses, cranes, overhead doors, hoisting equipment, and machine tool control. Plugging. Plugging is a method of motor braking in which the motor connections are reversed so that the motor develops a counter torque that acts as a braking force. The counter torque is accomplished by reversing the motor at full speed with the reversed motor torque opposing the forward inertia torque of the motor and its mechanical load. So plugging a motor allows for very rapid stopping. Although manual and electromechanical controls can be used to reverse the direction of a motor, a plugging switch is normally used in plug-in applications. They're designed to open and close sets of contacts if the shaft speed on the switch varies. A plug switch may be used to plug a motor to a stop each time the stop push button is pressed. So plugging can also be used for emergency stops. It can be used in an emergency situation. In this circuit, the motor is started in the forward direction by pushing the run push button. That's going to start the motor and adds memory to the control circuit. And as the motor accelerates, the normally open plugging contacts close. Pushing the stop button de-energizes the forward starter but does not energize the reversing starter. That's because there's no path for the line 1 power to reach the reversing starter, so that motor is going to coast to a stop. Pushing the emergency stop button is going to de-energize the forward starter and simultaneously energize the reversing starter. And that's going to be your plugging method. Plugging limitations and disadvantages. So your motor must be a reversible motor to use plugging. It must be capable of reversing at full speed. Plugging causes excessive heat and current, and that current may be 3 or 4 times more during plugging than normal operation. Plugging cannot be used often, and it should only be used as a fast stop. And the reason plugging cannot be used often is because it does create that excessive heat and current. It can destroy components of your motor over time. Electric braking. Electric braking is a method of braking in which a DC voltage is applied to the stationary windings of a motor after the AC voltage is removed. Electric braking is also known as DC injection braking. Electric braking is an efficient and effective method of braking most AC motors. Electric braking provides a quick and smooth braking action on all types of loads. And that's going to include high speed and high inertia loads. Maintenance is minimal because there are no parts that come in physical contact during braking. So that's an advantage of electric braking. In AC induction motors, the opposing magnetic fields are induced from the stator windings into the rotor windings by transformer action. The motor continues to rotate as long as the AC voltage is applied. Then the motor is going to coast to a standstill over a period of time when the voltage is removed because there is no induced field to keep it rotating. Electric braking can be used to provide an immediate stop if the coasting time is unacceptable, particularly in an emergency situation. Electric braking is accomplished by applying a DC voltage to the stationary windings once that AC voltage is removed. The DC voltage creates a magnetic field in the stator that does not change polarity. And the last one is dynamic braking. Dynamic braking is a method of motor braking in which a motor is reconnected to act as a generator immediately after it's turned off. Connecting the motor in this way makes the motor act as a loaded generator that develops a torque which rapidly stops the motor. The generator action converts the mechanical energy of rotation to electrical energy that can be dissipated as heat in a resistor with a high power rating. Dynamic braking is normally applied to DC motors because there must be access to the armature via the brushes to take advantage of the generator action. Access is accomplished through the brushes on DC motors. Dynamic braking of a DC motor may be needed because DC motors are often used for lifting and moving heavy loads that may be difficult to stop. A motor drive, and we'll get to those on in motor controls too, can control the time it takes for a motor to stop. The stopping time is programmed by setting the deacceleration parameter. The deacceleration parameter can be set for 1 second or less up to a couple of minutes. And we'll move on to those in motor controls too. So just as a summary, we went over dynamic braking, electric braking, plugging, and friction brakes operated by a solenoid.